Hi, and welcome to another Hopper on microcontrollers video. I'm going to review a couple of RP 2350 boards, recent arrival from the Pi Foundation's new microcontroller. And I've acquired a couple of these boards, the ones that are, were first available. I've had them for a little while now, I've tested them, and I've got Hopper working on these boards. So let me explain. Well, this is probably a good review of which boards work best with Hopper, but it's a bit more general in sort of reviewing which of these boards is the best sort of value as well. From the Hopper perspective, the way you flash these boards is you upload it. You hold down the boot button and then you upload a UF2 file to them. The same way you would flash MicroPython or CircuitPython onto one of these boards. That's how you flash Hopper onto the boards. So with each release of Hopper, I do UF2 files for a couple of different flavors. Now, there's an enormous number of boards. So if I was to do a UF2 for every single board, that'd be a lot of work to do that every time I do a release, updates that many of them and test that many of them. So thankfully, I can just make a generic Pico hopper and a generic Pico 2 hopper. And these will work on pretty much all RP2040 or RP2350 boards. So with the exception of if it's got Wi-Fi, because they have different Wi-Fi chips. So I only support 2 Wi-Fi chips right now. Well, actually 3 Wi-Fi chips, because they changed Wi-Fi between these 2 Challenger boards. But it means I have to make specific UF2s for the boards that have Wi-Fi. And there is no Pico 2 with Wi-Fi yet. There is a Challenger with Wi-Fi. Anyway, and then I have these last 2 UF2s are in case you brick your Hopper. So you've written a program that boots into Hopper so quickly and runs around in circles, or does something funny with the console, with the serial console. And since the Hopper monitor uses the serial console, you could, load a Hopper program up that just keeps stopping you from, replacing it or connecting with the monitor. So what these no-load versions do is they are the Hopper. It's the same Hopper runtime, but it doesn't automatically load the current program from Flash and run it. So that you quickly use one of these to unbrick your board and then put the previous one back on. Anyway, short version, I want to make as few as possible of these. So one of the problems with that is I haven't found a way, because you can build your own one as well. You build the Hopper runtime using the Arduino IDE, so you could build it targeting your specific board as well. But it's nice if you don't have to, if you can just use one of mine. And one of the problems with the Arduino IDE is I can't find a way to programmatically tell at runtime how much flash memory I have. And I understand why it doesn't exist as a feature, because I'm probably the only one in the universe that wants it, because I'm trying to build the same UF2 for multiple different configurations. And the original Pi Pico only had 2 megs of flash. The new Pico 2 has 4 megs of flash. So when I build that UF2 file, I can now configure it for 4 megs of flash, whereas these I can only configure for 2 megs of flash. Which, when you've got even the little tiny boards like this, come with 8 megs of flash, or 4 megs of flash. This one's got 4. This board, I think this one has 8. Can't really see it quickly. It's probably on the screen somewhere. I just can't see it. But I'm pretty sure it has 8. But anyway, it means now the lowest common denominator is 4 megs of flash. And I've yet to have that be a limitation. There we go, 8 megs of flash. Because typically the runtime takes less than 1 meg, and then you've got the remainder. So right now it used to have a remainder of 1 meg. Now you've got a remainder of 3 megs. That's the built-in Hopper file system, so you can have data files on your Hopper system. Anyway, what else has changed with the Pico? I've griped about this for a while, is that most of the modern boards will have a USB-C connector, which is a bit more rugged and durable, and you can plug it in either way around. And it's now, like, decreed by the European Union as a standard. So these guys had the ideal opportunity with the Pico 2 to change from the micro USB to USB-C, and they didn't do it. Probably because they wanted it to be backward compatible plug-in, drop-in replacement. But I think it's silly. They should have replaced this. They should have upgraded this to a USB-C. My other gripe with this board is because it's, by making it identical to the Pico, it's now like 4 years old or 5 years old. Whereas every other board has more than one button. This one's got two. That's what's got three. This one's got two buttons. So every other new board nowadays will have a reset button at least. And then in addition to that, the other boards, like this one, if you look at like this board here, it's not just a boot button, it's a boot/user button, right? I think the Challenger might do that too. No, but the other Plasma does it. So yeah, boot/user. So what they've done is they've hooked up GPIO 22 to the boot button, which makes sense because the boot button, as it's used in the Pico, is only used to boot it into program mode, so that you can boot it so that it loads up. It appears as a USB drive, so you can flash it. After you've done with booting, you never use the button again. So what these other devices have done is they've said after booting, it's now a GPIO pin, so GP23 here, which is clever. So to find another, anyway, it's a missed opportunity, in my opinion. I think these guys should look left and right before they, release an update to their board. I don't think they even pay attention to what their competitors are doing. I don't think they care. But they're getting left behind. A lot of these have a lot more flash on them, and yeah, the socket there as well. All right. Other things about this board, they added two RISC-V cores to this board, which is exciting if you're interested in RISC-V, but it has no value to from the Hopper perspective, because I'm trying to support all these boards with one runtime, and none of the others have RISC-V, so I'm not about to go and play with it. The single biggest feature that's kind of nice on this board, well, other than speed and 4 megs of RAM, is that the new processor has a deep sleep mode, a proper deep sleep mode, which is very, very handy if you're going to be running your thing on a battery. It's one of the biggest weaknesses of the RP2040 compared to like the ESP32, for example, ESP8226, is that they have a deep sleep mode, that you can wake up the board by signaling a pin, and it'll go into really, really low power consumption mode. Now, in theory, this board now has that, but I don't have access to a way to use it yet. And the reason is because I use the Arduino Pico library from Earl Philhauer. And I've had this chat with him about it as well, and he just hasn't got around to it because he's a one-man show, trying to do a hell of a lot of work to get support for the 2350. So he will get around to it, or someone will, and then there'll be a deep sleep mode in this SDK, and at which point I can get the deep sleep mode working in Hopper. So I'm looking forward to that. It's going to make a difference for usability when you're running a data logger on battery power, for example. or this one as well, is running on battery power. It's got a LiPo connector here and a LiPo charger built in. Okay, let's do a quick review of performance on this device. I'll pause quickly and hook it up. All right, there we go. So I've got it. I'm just going to power it up. There we go. And this is another change I've observed, and it's experimental, so I don't know why. But you've been able to overclock your RP2040 board from Hopper for probably more than a year already. The default speed of the 2040 was 133 megahertz. The default speed of the 2350 is 150 megahertz. So that's not a really huge leap. I've tested overclocking at different speeds. The fastest I could overclock the 2040 was 270 megahertz. And by the fastest, I mean the fastest I could do it reliably. And even that, I don't run it by default in that mode. The fastest I could overclock the 2350 is double the default speed, which is 300 megahertz. And in the case of the 2350, I have managed to do this reliably. So, I pretty much always run it at 300 megahertz now, which is kind of cool. So I don't know if they did anything that, I don't know why they choose their default speed to be, half the maximum speed that's possible. So this is the Mandelbrot. It'll pause a bit at the end and we can see how long it took. So 300 milliseconds, which is pretty fast on a microcontroller. And I don't, I can imagine that they run it by default at a lower speed for power consumption, but if you're plugged into a serial port, who cares? Maybe for heat dissipation, I don't know. But I've been running it at 300 with all my testing, and I have yet to see anything go wrong. So, whereas that was not true of the Pico, I just kept it, I had, it didn't reliably run at the overclock speed on the previous device. So I reckon that's definitely an improvement. And just so to use the Pico 2 with Hopper, you just include the other board now. And why has it got a different board definition? Well, it's because some of the pins, well, in this case, they've made it backward compatible and the pins haven't changed. But that might not be true for all the other boards, that I've been testing. So the pins might change from generation to generation. Because for Pimeroni, the tiny 2040, there's now a tiny 2350, right? So, if I run this now and it's the, classic blink program, we've got a blinky LED here and it's automatically found out which is the default pin. So the LED method is just working, LED property. All right, let's move on to another board, shall we? So I can stop that, exit that. Let's switch to there. Let's unplug this guy again. And what are we going to look at next? Right. One of my favorite boards by far is this little tiny board from Pimeroni, right? And one of the changes they made with it in this one is they added a quick, I2C socket on the back. The original didn't have that. So if we have a look at those, the original, here's the original, the 2040, didn't have that extra I2C socket. And even though it had two I2C controllers, you can see them in the pinout as, SDA SCL1 and SDA SCL0. It only had one SPI controller exposed. So you couldn't use a second SPI controller. If we look at the new one, the 2350 now has a second SPI exposed, SPI1 and SPI0. And it's got, I2C 1 and 0 controllers because the RP2040 had two controllers for each built into the chip. and then they added this extra. I didn't even notice originally. Earl pointed out to me when I said, he'd given the wrong pins for the defaults in the board configuration for I squared C, and he was absolutely correct. These are now the default pins. I didn't even know where GP12 and 13 were, and I was staring it in the face. I just didn't look for it. So that's pretty neat, putting that in. So this is a good value board. It's got my favorite hardware things like USB-C and a reset button, which is also, and the boot button's also a user button. It's got a lot of pins exposed for such a tiny board. It's smaller than my thumbnail, and it's like $8 or something, £8. There we go. It's good value. So I like these little boards. I do a lot with them. So it's my utility board, basically. So that's this little board. My other favorite board for a while has been the Challenger board. And it's the only one other than the Pico W that has decent Wi-Fi in it. That's a decent board. Now, Arduino makes something called the RP2040 Connect, and I try to get that to work. And same issue I have with the Raspberry Pi. I actually broke the my micro USB off on one of those. I've got more than one of them, but I don't like them at all. A little, and they're difficult to program. It's difficult to get it to work with Hopper. Whereas the Challenger boards have been an absolute pleasure to get working with Hopper. So this is the original one, the RP2041. This is the Wi-Fi antenna here at the end, that little bar. And let's have a look at what the new one looks like. So they were one of the first to release an RP2040 board, and definitely the first to, as far as I know, to put one on with Wi-Fi. And they've got you can see the ESP32C6 in a can for Wi-Fi. So it's a little bit bigger than the previous board. It doesn't sit flush because they put the single wire debugging on the bottom, and this might be a flash chip on the bottom as well. So it's not as flush anymore, whereas this one was flush with it, so you could just glue it onto your project. Anyway, so great little board this. Really easy to get it up and running. As I mentioned earlier, because of the Wi-Fi specific nature of it, I've got UF2s specifically for these two boards, and they have a variety of boards in their Challenger range, and they've been calling this their Challenger Plus range to indicate it's different. It's got the RP2040 on it, so they've got like data loggers. I've got a couple of their boards, so like this is a data logger, so it's got its SD card, and it's got USB. It's got a LiPo battery charger and connector. One of the things that's a little annoying about the iLabs boards is they got their power leads for these LiPo power connectors the wrong way around. And what do I mean by the wrong way around? I mean, like, if you look at these, they always come with a red and a black lead, and they always come with a little, like pre-made, pre-wired socket plug on them. And they're the wrong way around for plugging into these boards. What they did with this board is they upgraded to a smaller connector. So it's got a much smaller connector now. So what do they call that? 1 point something, 1.2 instead of 2.1 or something. Yeah, a 1.25 mil JST, whereas the previous ones used to use the 2 mil or 2.1 mil JST. So it's a tiny little plug, which is nice because the previous one, where is it? You look at the difference in size of those and the profile as well. And when the pins are basically the same size, why have such a big socket? But it does mean you've got to be careful. So I got little adapters to test it. So a little connector, and I had to cut it and rewire it and change the black to red, swap them around. And that's my little hint to myself that, this is that red and black are the wrong way around so that it works with that socket. All right. And I think they might have done that as a mistake originally, and now they're stuck with it, because if they changed it, they'd probably really confuse all their customers. They've also got their own little serial bus connector here, like that tiny little thing there. They've had that in the previous version as well. It's a little ribbon connector for I2C, their own standard. They used to have a NeoPixel on board. They tossed it. I guess nobody cares. And it gave them some more board space, because the NeoPixel probably chewed a little bit. Maybe it was cost. Don't know why they did it. Anyway, very happy with this board. Works beautifully. And yeah, I've tested the Wi-Fi with Hopper. And I'll make individual videos if people are interested. So just comment if there's one you want to see, or if there's a board I haven't reviewed you want me to review. Just throw me a comment on that. So once again, to me, this is the winning board. It's not as cheap, obviously, as the Tinies. What does it cost? Let's look at it in US dollars. It's $25 US for this board. Or if you're thinking in euros, that's 23 euros. So 23 euros versus 7 euros. Anyhow, to me, that's the winning board. So if you want all the functionality and all the GPIO pins, I'd recommend this board. None of these people give me any products or anything. It's not like I'm sponsored by anyone. But so I'm definitely, I have no horse in the race, and I picked this one anyway. Now, another board that I got, which is kind of interesting. The only reason I got this one is because it was one of the very first ones that was out with the 2350 in it. It's also a Pi Moroni board. But there's some peculiar things about this board. It has an RGB LED. Like, why bother? I mean, this thing's designed for driving. This board has one purpose: is to drive like strings of NeoPixels. This sort of thing. Strings of NeoPixels. So peculiar that they put an RGB LED into it. I guess it didn't cost them anything. It's got 3 buttons, which is nice. Including, it has a reset button, and the boot button can be used as a user button. It has an I2C connector here. But there's something very odd that they did with this board. Take a look at those pins. Can you see they don't line up? They're in like a little zigzag. So you can't just drop in headers and throw them into a breadboard. And there's no, other than these 3 analog pins, which are also GPIO pins, there's very few GPIO pins. This is single wire debugging interface over here. So there's like 1, 2, 3. I don't know what int is. But 4, 5, 6, 7. So 7 GPIO pins on this board. But it's capable of driving, I think, 3 amps worth of LEDs. So I'll pause the video and set this up as a demo. All right, I've got this demo up and running. So all I did is I wired a string of these LEDs directly into this plasma board. It's got this nice terminal block on the end, so you don't even have to solder or use a breadboard, just screw in the leads. So if your thing is, Christmas tree lights, you can get a long string of these, and it can actually host quite a long string. I had to butcher I've got a demo in Samples MCU, Blink Neo, and usually it'll set itself up automatically. But for this one, it wouldn't know how many I had in the string, so I just didn't use the default setup. I just set it up specifically, and at the same time told it which pin it was. I guess, I mean, I could have used, let's have a look. There should be, I could do, it's not saying which is the NeoPixel pin here, is it? There we go, built-in NeoPixel. So I could have done that. I could have done board like that. So the board does know which is the NeoPixel, but it doesn't know how many are plugged in. So I've got to put that 10 in there because I've got a string of 10. Anyway, my demo just runs through the string one at a time and switches them between, RGB and then black again. But this is one of the standard Hopper demos for NeoPixels. But I've seen some pretty cool things being done with NeoPixels, and one of the most interesting things I've seen is these rock climbing walls, training walls, which light up the different holes. So they've got strings of these LEDs behind each hole, and then they've got a translucent back to every one of the climbing grips. And they show color coding to show what the grips are for. So in this case, you're supposed to start the problem with your hands on the green and finish your problem with the hands on the purples. And the blues are the holes in between, and the yellows are the ones that you can use the yellows for your feet, but not for your hands. So kind of neat, because what are they doing here? 1, 2, 3, 4 colors, and you can use a phone app to choose your problem. So you can dial in one of thousands of problems onto the board from a phone app that drives an LED chain. So this is it's called a kilter board, with all these holes slit up, a bit washed out in this photograph, but you get the idea. Anyway, I think this is one of the cooler things that I've seen done with NeoPixel LEDs. And in theory, you could drive this entire board off this little Pimeroni Plasma 2350. Be nice if it had, Bluetooth on it, so you could connect to it with your phone, but it doesn't. So you'd have to have more to it than that. One of the reasons I like boards that have Wi-Fi. Anyhow, I think that is the end of my brief review of new boards running the Hopper runtime. These 2350s. I'll probably get more of these boards in because as soon as they go into a store, they all get snapped up. So they're in quite high demand still. But I'll do more reviews on these boards as they come out. And if there's one you're interested in, let me know, and I'll get that one and have a look at it. So thank you for watching, and I'll leave you on that.